Hey everyone, Chang here. This is a skill building video series. For today's topic, we're going to go over how to graph multiple inequalities or multiple basic inequalities. Here's one right here. We have an x is greater than 7 and an x is less than or equal to 1. Now before I even go into details about how to graph this, here's the thing. There's, I guess you could say, a trick question or like very ambiguous or confusing ways of writing this problem. Here's one. When they ask you to graph it, they're actually not including, and hopefully they do, but if not, you really have to clarify. There's a difference between and or. What do I mean by that? We have an and right here, the word and the word or, okay? And means that whatever you graph, whatever you solve, it has to be included in all these statements. So it has to work for all of them. Okay, so whatever you graph, this has to be true and this has to be true. Or means at least one of those statements must be true. So it's going to be at least one. And this one I only have two, but then eventually you're going to encounter ones that maybe have 2, 3, 4, so on and so forth. Okay, and or. Now I wanted to clarify this because guess what? There will be situations where if they use the word and you try to graph it, and technically it's not possible. It's going to be no solutions, and if you graph it, they're going to say you're wrong, right? Same with or. Now, here's the thing. We have an x is greater than 7 and x is less than or equal to 1. I'm going to graph it really quickly. Without going into details, I'll go into details in a bit. But here we are. Okay. 0. We have 1 that we're worried about, and we have 7 that we're worried about. Not drawn to scale. Okay. Well, for the 7, it's going to be greater than, not greater than or equal. So I'm not including the 7 itself. I like using dot notation, so I'm going to just use that. Here's the dot thing, and it's not including 7, so I'm not going to fill that out. And it's everything greater. There it is. Okay. Now, x is less than or equal to 1. Well, here's 1. Here's the little dot thing, and then we want it less than or equal, so I'm actually including the 1, and then it's going this way. Notice this. 1 is going in one direction, 1 is going in the other direction. Now, if you use the word and, this is a situation where there's no solution. Technically, the real answer, no solution. Not possible. And make sure I emphasize that, no solution. Now, why is that? Well, in this case, look at this. Any number that's greater than 7 cannot be in any number that's less than or equal to 1, right? Kind of makes sense. Any number that's less than or equal to 1 cannot be in the situation where it's going to be greater than 7. So you can't include both. And remember, when they say and, both of them has to be true. And if there's more than 2, then there's all of them, right? This is not possible, so it's going to be no solution. But if they use the word or instead of and, that means at least one of them is true. And that means this works. It's not going to be no solution. That wouldn't be the case if you're using or, right? It would just be this graph right here. Because guess what? The number can definitely be any number greater than 7. Or it could be any number that is less than or equal to 1, right? It could be in one of those two statements, and that's entirely fine. So be very careful. If it happens to be something like this and they use the word and, then it's no solution. You can graph it, but make sure you emphasize there's no solution, because I know some of the, like, I guess instructors or anyone who creates that problem, it's going to penalize you if you don't do that, right? And if it's or, then it's always, or not always, but it's usually going to be a graph. So that's the difference. Well, in this case, let me explain what I did. I worried about one inequality at a time. I put the 0, I had the 1, I had the 7. Now on the top one, I just focused x is greater than 7. Here's 7. I chose an excluding, I guess you could say dot, right? Because we're not including the 7. Arrow's going this way because it's all number greater. Same with the 1. This is the second part. I'm done with this. I ignored it. Now we have x is less than or equal to 1. Here's 1. Included because it's less than or equal, and it's everything less than. There you go. And that's how I graph this one. Now for the second problem, it's the same thing, except for now it's not as easy. We actually have to solve each and every one of them first, isolate the variable, and then we can graph them. So for the first one, we have 4x minus 2 is greater than 6x plus 8. I'm going to subtract 4x here, subtract 4x here. This goes away. So we have minus 2 is greater than, and 6x minus 4x is 2x plus 8. Okay, subtract 8 right here, subtract 8 right here. That's going to give us negative 10 is greater than 2x. Divide by 2, divide divide by 2. Now, common mistake, right? I'm dividing by 2. Even though this technically is dividing, I guess you could say, a negative number, both sides actually divided by positive 2, so we don't switch the inequality symbol. So, right, so we have x is what? Well, in this case, less than or negative 5, right? Because negative 10 divided by 2, negative 5 is greater than or equal to x. There it is, okay? So that's our first portion. I'm going to erase this, and then we're going to work on the second portion. I'm just going to keep the answer on the board, so let's just do this. So it's going to be negative 5 is less than x. I believe that was the answer, okay? Now, for the second part, we're just going to solve that as well. We have a 1 minus 5x is greater than negative 1 plus x. I'm going to add 5x on both sides. There it is. And this is going to give me 6x right here. This is a negative 1 plus, and then we have a greater than symbol, and we have a 1 right here. I'm going to add 1 on both sides. And then what happens? Let's see. Okay, so I have 6x is now, well, this is greater than symbol, and then we have a 2. Okay, anything else? Let's see. Okay, now we have to divide by 6 on both sides. And so technically we have, let's just write it right here. 2 over 6 is greater than x, or if you want to simplify it, it's going to be 1 over 3 is greater than x. Okay, that's the second part. So I'm going to erase all this. I'm going to just write it up here so we can actually see the two inequalities. Okay, here we go. Erase, erase. And we have a 1/3 is greater than x. Okay, here it is. Well, let's just get rid of this too. And then we're going to start graphing it. We draw a number line. Here it is. The lovely number line. We have a 0, and then one of them is going to be 1/3. That's on the positive side, so it's roughly right here, not drawn to scale. And the other one is a negative 5, so that's going to be on the negative side. It's right here, once again, not drawn to scale. Okay, so x is everything, I guess you can say, is smaller than negative 5. So everything smaller than negative 5 is going this way. So not including, so it goes this way. And then 1/3. X is everything smaller than 1/3. So this way. And it goes there as well. Hopefully you guys can see that. Okay, so x is smaller than negative 5, going that way. X is smaller than 1/3, going that way. Okay, now here's where it gets a little tricky. Once again, remember, we have our little and or. And or. Okay, if it's an and, guess what? The actual graph in this case, this wouldn't be included. The reason for that is because whatever number is in here is not actually smaller than negative 5. So if you were having to graph this, I guess you could say these multiple basic inequalities, what's going to happen is that the actual graph is going to look almost the same thing. Hopefully you guys can see that. It's going to be 0, 1/3, and negative 5. And means that both these statements are true. That means when you graph it, it only can be this guy right here. Because that all the numbers right here that is smaller than negative 5 is true on both of these statements. If it's an or, then the first one is going to be okay. So that's why you got to be very careful. And an or is extremely different. So this is an or solution. This right here is an and solution. So for the remainder of the video, I'm going to refrain from giving explicit explanation. Pay careful attention to the and or. Remember, and both statements must be true, or either one must be true. Okay? Thank you for watching this video on graphing multiple basic inequalities. Until next time.